Hi, I'm Avner Kreps,
And I'm Ben Fearon.
and this is our It's an Element Lab presentation.
So in this experiment, we are given an unidentified metal and are asked to identify it. The purpose being to learn about the chemical and physical properties of metals and how one can experimentally test for those properties.
Our hypothesis for this experiment is that it is possible, through experimental tests of the physical properties of our unidentified metal and through comparison of those properties to the known properties of other metals, to determine the identity of this unknown substance.
Density is a physical property of metals that is very telling about the identity of that metal. Most of you probably know how density is found and measured, but just as review, it's measured in grams per milliliter, and we found mass, or grams, by taking the mass on a mass balance, then dividing that by the volume, which we found through water displacement.
The other test we're going to be running is finding the specific heat of the unknown substance. And as most of you know, I'm sure, specific heat is how much energy a substance can absorb if a gram of it is heated by 1 degree Celsius. Now, the way we tested this was by taking the mass of the substance, we raised its sample to a known temperature by placing it in some boiling water and letting it sit until its temperature reached 100 degrees Celsius, and then we placed it inside a calorimeter containing 100 milliliters of distilled water at a controlled room temperature. We waited until the temperature of that water stabilized, and then we had all the tools we needed through some quick calculations to figure out the specific heat.
In our experiment, we had 3 trials. In each trial, we tested for the mass of the sample in grams, the volume of the sample in milliliters, the initial temperature of the sample in degrees Celsius. Note that this is the initial temperature when we had it in the boiling water. We had also the initial temperature of the water that was in the calorimeter, which is about room temperature, and the final temperature of the water after the metal was placed in the calorimeter and it equalized.
So here we have our calculations for density. As you can see, these calculations are very quick and simple, just one division problem, and the values that we obtained are about 2.9, 2.8 grams per milliliter.
The formula for calculating specific heat is Q equals mc delta T. What we did first was find the Q for water in our experiment, which we did by using its mass and delta T and specific heat to solve for Q. We used the same Q as our Q for the sample because we let the sample and the water equalize in the calorimeter. Now, when we had the Q for our sample, we were able to also use the delta T for our sample and the mass for our sample to solve for C, or the specific heat for our sample. In the example here, we got about 0.86 joules per grams degrees Celsius, but our average was closer to 0.81 joules over grams degrees Celsius.
So here's a graph of our data. It's graphing the specific heat and density of our sample as compared to 4 common metals. So as you can see, the density of lead and iron is way too high for our sample to be one of those 2 metals. Therefore, we can rule those out. And while calcium is closer, its specific heat and density are both a little too low to match up. As you can see, aluminum's values are very, very close to our own samples, and therefore we concluded that our sample was aluminum.
With the conclusion that our sample is aluminum and the fact that aluminum's physical properties match so closely to our samples, it implies that it's extremely and quite easily possible to find the identity of any unknown metal, and this verifies our hypothesis. In the future, we could try the same experiment on other phases like liquid gas or plasma, or we could, instead of doing physical tests for physical properties, we could do chemical tests and test the chemical properties of our substance.
Now there were a few errors in our experiment, such as the loss of heat of the substance in the transfer from the boiling water to the calorimeter, as well as inside the calorimeter itself. There could be some human measurement error in the volume by our mistakenly accounting for the meniscus as part of the volume of the water, and other small factors, such as heat contamination in the thermometer, or some droplets of water remaining on the substance in between trials.
Thanks for listening. That's the end of our presentation. These are some people and organizations that helped us during the experiment.